So I decided to try this new Genius Depth 3D software program I learned about yesterday. It's in beta mode, so I don't know what to expect, but I thought I'd take a look at it and see what I can learn. So I prepared a file, and I'll launch Photoshop here and come over to this document. So this is basically a digital image, and then if we go to the layers palette, you can see there's a depth map with that. Now, this isn't a great depth map. I'll be the first to admit that. I don't even remember how I generated this. It was probably a couple of years ago using some software-based online tool. So not terrific, but for the purpose of this demonstration, it should be fine. And if you look, there are errors in it. You can see by the edge of the spoon, the little mouse's finger should be there, and they're not. So first thing I'll concede is it's not maybe the most perfect image to use, but it was one that I was able to find quickly on my computer. Now, there are two layers here, the top labeled color 1 and the bottom labeled map 1, and it's essential to label them like that. When I first made this file, I just had named it something like RGB for the color part and depth map for the depth map, and the software wouldn't accept it. It said there was a height error or something like that. So I contacted Alex Krew, who I believe is the person who created the software, and he wrote me back and said, rename your files in a specific manner, and I did that, and after doing that, everything worked out just great. So we'll close this and minimize Photoshop, and so now we're in his software. Now, this is all in Spanish. I'm not a Spanish speaker, but I was able to take my cell phone, use Google Translate, and see what all these things mean. So basically, this is the width of your file in millimeters, the height in millimeters. This is the border that goes around the image for alignment purposes. And then this is basically settings for near and far depth, which for my purposes, I'm going to leave at their default. And then volume, you'll see how this works when I actually open up a depth map, and then some anti-aliasing, a simulator where we can animate these files, and then a way to export the 3D interlaced picture. So let's begin. Actually, the exportation's on here. This is to open a file. So we'll come over here, and we'll come up and go here, grab the document. So now you can see on the upper left, there's the RGB image, and there's the grayscale depth map. And there's a preview here in the center of the screen, and it has a watermark on it because this is just trial software. It's not the final version. So I had measurements for this file, which I've already forgotten. Let's see, did I write those down? No, let me go back to Photoshop and open that back up. Oh, 180 wide by 120 high. Okay. So we'll go here to 180 wide, and then this is a 121.88. I believe that's due to the registration border. Don't know that for certain. So we're going to leave these near and far values the same. We're going to leave the depth volume at 1 and the anti-alias at 5. These are all the default settings. I'm going to use a 60 LPI lens, which actually measured 60.1, and I'm going to generate 24 frames. So why 24? Well, why not? I'm basically using the old formula, 720 PPI for my printer divided by 60 LPI for my screen gives 12 frames. I always like to double that, so I'll use 24, and that's how I came up with this value. You could use more, you could use fewer. This is how I work. All right, so I'm going to hit this animation button, and you can see on screen now the files moving back and forth. You see a little bit of tearing by the spoon. There are some ways of controlling that, but whenever you have something like a white tone against pure black, like we have up here in the depth map, you may get that kind of tearing. So that's one of the advantages of using layered files with depth maps, is you can put each layer give it a different depth map and you don't get that tearing. But this software doesn't work that way. So if you want to reduce that tearing, you can use this anti-alias and you can slide that up a little more. It's never going to get rid of it completely. Now, I will say prior to starting this video, I actually used this software and I made 3 or 4 different prints using different values for the depth, the aliasing, and so forth. And when I did the standard anti-aliasing setting that was the default, that worked out just fine. So what I want to do now is have you look at this depth map on the upper left. And if I take this volume slider, which is at 1.0 right now, if I increase that, you can see the foreground areas, the whites are getting clipped. They're going all pure white. And likewise, if I take and move that to the back, you can see ultimately the trees are going completely black. So what you want to do if you're going to use this 1.0 setting, you want to make sure you have a full range of tones from 0 black to 255 white. And if you don't, I can show you a little later in this video how you can fix that in Photoshop. So I have my dimensional parameters set. We're going to keep these defaults. I'm going to come over here and make sure I have my 60.1 LPI. That's right, 24 frames. Now we're going to export this file. So we export that. And I've made a variety of them, as you can see. I'll just call this latest test. And I'll hit save. And then just below this export demo button, you'll see a little progress bar. So that's a little thermometer bar going green and slowly moving from left to right. Now, dimensionally, the file I made, it's fairly small. Probably could grab one of the printouts and show you. It's about 7 inches wide. All right, we're almost done. We are done. So this message comes up and it says the render is finished. We'll hit OK. Now we'll come over to Photoshop and we'll open up that render file. So it's saved it in TIFF format. Now I was told by Alex, what you want to do is come and resize this to your printer PPI. So it generated a file at 1442.4 pixels per inch. We're going to take and make that 720. And you just do that to send a file to the printer in its native resolution. So that is our picture. Now if I go to print it, I would go File, Print, pick my printer here, print settings. I would come over, pick the parameters for my Epson printer, use the correct color profile, and hit print. Now, actually, I have my printer turned off right now, so it's not going to print, but I have made some prints in the past. They turned out nice. I was actually impressed. I did the one with the standard 1.0 magnification, and then I tried one 2.0 where everything went white, and I have to tell you, that actually turned out to be a pretty dramatic picture. The only problem I had with it was because the white clipped in the foreground, the hedge and the pots and the front of that cheese block were all up there. But boy, Remy the mouse looked great. So to fix that, what we have to actually do is change our depth map parameter. So I'm going to take this and minimize it. I'm going to come over here and I'm going to grab the file we were working with. So here's our picture. And if you look in this window, here's something called the histogram. Now I'm going to turn off the color. We're just going to look at the depth map, and you can see, oh, here, there's really nothing that's black, and there's not really the pure whites. And if we come over with our eyedropper and maybe grab here and this background. So this background number 3, it says that's at 27, so it's not even 0. This foreground pot number 2, that says it's 223, 223, 223, so very light, but it's not pure white like 255. And our black, we already talked about our black, our Remy is at 178. So value 128 would be at the surface of the lenticular sheet. And so 178 means Remy is going to come forward off the sheet. And that certainly saw that in the prints. So how do we fix this histogram? Well, the quick, fast way is just come over here, go auto contrast. And now you can see the histogram is using that full range of tones. So the background is now 22. The foreground is 233. That could be made even a little whiter if we wanted to, but there could be other areas that are even whiter. If I click this part here, see that's 255, this little section of the bottom right corner. Anyway, so it's just a quick way of taking your histogram using the full range of tones, which for software like this would be very helpful. So with that, let me not save that. I guess that's my opinion or my experience with the software. Actually, I do have some opinions of the software. I think it's cool. I think what's really neat is you don't end up with this folder of all these individual frames. You end up with just a finished export. I can see in the future where maybe software like this you would just import an image and it would generate the depth map automatically. And maybe you just put in the LPI value you want and it determines the number of frames, so the user doesn't have to. If I were to make some suggestions for improvements right now, I would have a English metric switch, so anyone that's in the US can use inches instead of millimeters. What else? How else would I improve this? I guess maybe work on this tearing here. I know there are a lot of ways of generating 2D to 3D images. If you ever look at like a Facebook 3D image, instead of that kind of distinct tearing, it has more of a blend, a pixel blend, which is kind of nice. And I think that alone would probably really greatly improve the output. So all told, for beta software, pretty good. I don't know how long it took him to develop this, but I think he's really close to a release version. It would be great for someone who's new to lenticular because it's getting rid of all sorts of pain points. You don't really have to worry about generating all the individual frames. It's nice just to get that final output. So those are my thoughts on Genius Depth 3D. Why don't you download it from his link and give it a try?